For this next part, we're going to look at lines and their equations and see a bit what we can do with lines. Lines are ubiquitous in coordinate geometry, so this is also going to be an important topic. So generally speaking, there's two big sets of equations for lines. There's one equation that looks like y is equal to mx plus q. That's for a line that is not parallel to the y-axis. And then on the other hand, there's x is a for a line that is parallel to the y-axis. And in this first equation right here, m is called the slope. So it tells you how quickly the line goes up or down. And the q is the intercept, which tells you where it meets the y-axis. So let's do a couple of examples to see if this makes sense and to see what we can say about a line. So for the first, I'll take y equal to 3x plus 1. And let's try to draw that. So we know that any 2 points, different points, determine a line. So in order to graph the line, let's calculate 2 points that are on it and then draw a straight line through it. If I put x is equal to 0, I will get that y is equal to 1. And if I put x is equal to 1 in this equation, I get that y is equal to, and let me write in a very childish way, 3 times 1 plus 1 is equal to 4. So the simplest calculation but worked out. So that tells me that the point 0, 1 is on my line, and the point 1, 4, which is probably here, is also on my line. And therefore my line looks like this. And I have a nice drawing. So let's look a bit at these parameters, the intercept and the slope. So if I take my general equation, y is equal to mx plus q, and I set x is equal to 0, then what I get is that y is equal to m times 0, is 0, y is equal to q. So by setting x is equal to 0, I always end up with q for the intercept for the y coordinate. So here too, I see the intercept was 1, and that's the 1 that I have here. And more generally speaking, on the figure, the length of this line here, which is 1, that's my intercept. On the other hand, now let's take a look at the slope. So if I take my, or actually let's have a look at my written out equation here. What I basically did by writing this out is here I have the intercept q, and then here I added the slope m to it. So graphically we can represent it as we went to the right by 1 unit, and then we had to go up like this by 3 units, and that just happens to be the slope to end up at 0.14. And this is a general thing that holds true. So with a line, the interpretation is if you go to the right by 1 step, you have to go up or down by however many times the slope is. So let's summarize that. So the intercept q is where the line meets the y-axis, and the slope m is, if I go to the right by 1 step, how many steps do I have to go up or down. And you have to go up when the slope is positive and down when the slope is negative. So let's look at another example here. So for the second example, we'll take y equal to minus 2 times x plus 5. I know my slope is 5, so that line is going to meet the y-axis in the point with coordinates 5. And now the intercept is 5, and the slope is minus 2. So I know if I go to the right by 1 step, I have to go down by 2 steps to get another point on the straight line. So this point right here, if you calculate it, you'll have coordinates 1, 3, and we can check that that indeed is a point on the line. And our line therefore looks like this, goes down and down. So for the third example, let's take y is equal to 1. And y is equal to 1, you can write it as 0 times x plus 1. So from that, you see that the slope is 0. This line doesn't go up or down. It's a horizontal line. Or in other words, it's a line that's parallel to the x-axis. And then where does it hit the y-axis? Well, it still has intercept 1, so it meets the y-axis in the point 0, 1 here, and then continues horizontally. For the last example, we'll take a line with equation x is equal to minus 2. So that's one of the second type here. And we know that those are lines that are parallel to the y-axis. And we can see where it meets the x-axis from what's on the right-hand side here. So this line will meet the x-axis in a point with coordinates minus 2. And then it's going to run parallel to the y-axis like this. So graphing lines is generally quite useful, but what you also have to be able to do is derive the slope and the equation of a line given some elements, some points on the line. So let's turn to that next. So let's start with an example. Let's take our axes like this, and let's take a point here with coordinates 0, 2 and 3, 0. So now I want to find the line that goes through these 2 points. I want to find this line. So there's a couple of things that we can read off already from the figure. So for the intercept, I know that the line hits the y-axis with y-coordinate 2, so the intercept is equal to 2. For the slope, on the other hand, what I can do is, I know that by looking at my figure, if I take 3 steps to the right, I'm going to have to take 2 steps down. So 3 steps to the right means 2 steps down. Let me write that down a bit more formally. So 3 steps right means 2 steps down. So 3 steps right means that if I take 1 step right, I have to take 2/3 of a step down. And from the interpretation on the previous slide, that tells me that my slope is going to be 2/3. But since I'm going down, the slope is negative, it's minus 2/3. So eventually we get for the equation of our line that y is minus 2/3 x plus 2. So more generally, so let's look at the general case. Let's say we want to find the line that goes through two completely arbitrary points, P with coordinates x1, y1, and Q with coordinates x2, y2. This line. Then what I can do is I can look at this right angle triangle that's given by like so. And so I know that this coordinate is x1, this is x2, and this is y1, y2. So now let's go look inside that triangle one more time. And so we also know now that the lengths of these sides, so this thing right here, that's delta x, which is the difference between x1 minus x2. And this thing right here, that's delta y, y2 minus y1. So it's a bit small, but I hope you can see. So what that tells me about my slope is that if I continue on the right hand side here, is if I go delta x steps to the right, then I have to go delta y steps up or down. And again, for one step, right, that means that I have to go delta y divided by delta x steps up or down. And from that, it follows that the slope m is delta y by delta x. And actually, let me write it in full. So that's the difference between the y coordinates divided by the difference of the x coordinates. And here you have to be careful. Sorry. You have to be careful because x1 should not be equal to x2 here. Otherwise, you divide by 0 and the slope just doesn't exist. So the points here, they can be in arbitrary order, P and Q. You could swap them. The M will still be the same. The formula also takes care of up or down. It'll be negative when it's down and positive when it's up. You don't have to worry about that. So let's plug in the values that we had on this here. So let's say P is 0, 2 and Q is 3, 0. Then I have that my slope is the difference of the y coordinates, so 2 minus 0, divided by the difference of the x coordinates, 0 minus 3. So we again get to negative 2/3, just like we had here. So let's work with that a little bit. And let's do a quick example. So let's find the line through the points 1, 5, and 2, 7. So, well, first of all, I know that the slope is the difference between the coordinates. So y coordinates first. 5 minus 7 divided by 1 minus 2. So that is negative 2 divided by negative 1, or 2. And so next we want to compute the intercept. So we know now that y is 2x plus q. And to find the intercept, we can substitute one of the points. So we know, for instance, 5 is equal to 2 times 1 plus q. and therefore q is 5 minus 2 or 3. And as a result, we end up with 2 times x plus 3 for our line. You can substitute these points back in the line. You should get that they indeed are on there. If they're not, then you've made a mistake. So let's do a quick other example. Let's find the line now through 1, 5, and 1, 7. So I'm changing the x-coordinate of this point here. And now if we calculate the slope, we get difference of the y values, 5 and 7, difference of the x values, and we see here negative 2 over 0. That doesn't make sense. You can't divide by 0, so the slope does not exist. That means that you have a vertical line, a line that's parallel to the y-axis, and in fact the equation of this line is y is equal to 1. So you can see that we have 1 here and 1 here. So now two important formulas, and I'm not going to do any examples because the previous slide was sort of an example on that. In general, if you have given a single point and you're given the slope, then your equation for your line is going to look like this. So you take y minus the y-coordinate of that point that you're given equal to the slope times x minus the x-coordinate that you're given. And now if you keep in mind that the slope is always the difference between y-coordinates divided by the difference between x-coordinates, then you can also see how the next formula arises. So now if you're given 2 points, but you don't know the slope, then what you have to do is calculate the slope and use that here instead of this m parameter. So this here is the slope again. And now let's move on and talk about parallel and perpendicular lines. So we say that two lines are parallel if they have the same slope and two lines, so parallel lines, let's make a nice drawing, are basically lines that run next to each other that don't intersect. So these two lines are parallel. And then contrary, two lines are perpendicular and so here it's two lines with slope m1 and m2 if m1 times m2, so if you multiply the slopes, if you get minus 1. And so perpendicular lines, no surprise here, but those are lines that make a right angle, like so. There's actually a small proof involved in deriving this expression for the slopes, but we will not cover that in this lecture. So just keep in mind, perpendicular means the product of the slopes is minus 1. So let's look at an example of that to get that in our fingers. So we'll take two lines. And the first line has the equation x plus 2y minus 3 is equal to 0, and the other one is k times x. So k is going to be some unknown parameter, plus y minus 5 is equal to 0. And for the first thing, we'll ask, well, for which values of k are L1 and L2 parallel? So parallel means the same slope. So let's look at the slope of line 1. Let's call that M line 1. In order to do that, we'll take the equation and we'll write it in our familiar y is equal to something form. So here we have y is equal to minus 1/2 x plus 3 over 2. So from that it follows that the slope of line 1 is minus 1/2. And then likewise the slope of line 2, we have k times x plus y minus 5 is equal to 0. And if you make that into y is equal to something, you get y is minus k plus 5. So the slope of line 2 is equal to minus k. And from that, we know that the two lines are parallel if their slopes are the same. So ML1 is equal to ML2. So that means that negative 1/2 is equal to negative k. And that means that k is equal to 1 over 2. And now let's do another example here. So for which values of k are they perpendicular? So in that case, the slopes have to multiply to minus 1. And we already have the values of the slopes, so we know minus 1 times minus k has to be equal to minus 1. And from that, if we clear that out, we get that k is equal to minus 2. So for the next topic, we'll talk briefly about the distance from a point to a line. This is a very useful formula. So briefly, let's say we are given a point P here with coordinates x0 and y0, and we have a line and we'll call it L with equation ax plus by plus c is equal to 0. And one thing to keep in mind, so for this formula, it's very important that you write the line in this form. So it has to be equal to 0, not equal to something else. And so the distance from that point to the line is what you get if you draw a perpendicular line like this. And this is going to be our distance, let's call it capital D. So then the distance is given by the following formula. So you take the equation of the line, you substitute the point, you take the absolute value, and you divide by square root of a squared plus b squared. So let's do a very quick example. Let's say our point P has coordinates 0, 1, and our line has equation y is equal to x minus 2. So we can write that as minus x plus y plus 2 is equal to 0, and therefore the distance becomes the absolute value of, you substitute 0 for x, so minus 0 plus 1 plus 2, and then the square root of minus 1 squared plus 1 squared, and if you work all of that out, you should get 3 divided by square root of 2. And to finish up, let's talk briefly, recap the representation that we've seen of lines. So we've started off with the slope-intercept representation, which was of the form y is equal to mx plus q for a line that's parallel, that's not parallel to the y-axis, or x is equal to a for a line that is parallel to the y-axis. And we also saw in passing a linear representation, which is given by ax plus by plus c is equal to 0. So you can always convert this back into the slope representation, at least if b is different from 0, and you will get minus a over b x minus c over a if a is different from 0. And so you see that in that case minus a over b is the slope, and minus c over a is the intercept. And then two more representations that we haven't covered, but for the sake of completeness, there is a polar representation using polar coordinates. And so for this, let's take our axes and let's quickly think back about what polar coordinates tell us. So polar coordinates describe points not by coordinates x and y, but they look at the distance to the origin, r, and the angle that is made with the positive x-axis, theta. And in order to go from polar to Cartesian coordinates, you have that x is r times cosinus of that theta, and y is r times sine of theta. And so now if you substitute those expressions for r and cos and theta in the slope intercept representation, then you get r sine theta is m times r cosine theta plus q, and that is equal, if we bring all the r's to one side, r times sine theta minus m cosine theta is equal to q, and from that it follows that r is equal to q over sine theta minus m cosine theta. And then last, for the sake of completeness, there's also a vector representation where we write the point on the line, point P, as a vector in 2 dimensions with coordinates x and y. And so here the equation of the line becomes x, y is, well, x is x, y is mx plus q. So you can also write that as x times the vector 1m plus the vector 0,